Hello, my name is Ashiya Satar from the University of South Africa, and I'll be speaking about quantitative research, the approach, analysis, and interpretation thereof. Before we continue, I'd like to inform you of what will be covered in this presentation. Firstly, I'll provide an overview of quantitative research, what it is and what it's not. I'll provide some quantitative terminology so that you can understand some important terms related to quantitative research. We'll move on to sampling, understanding generalizability, some sampling techniques and limitations thereof, the issue of validity and reliability in practice, construct development in terms of operationalization and itemization, and stats basics. I discuss your statistician, understanding some statistical procedures, and how to use these results. It should be noted that this is a very basic presentation on the basic concepts and basic approach to quantitative research so that you can understand how to approach research of this nature. All right, before moving into an overview of quantitative research, we need to understand what research is. Research is a studious investigation with the intention of discovering new facts and conclusions based on a structured approach to knowledge acquisition. What then is quantitative research? Well, quantitative research is a method of research that relies on measuring variables using a numerical system and analyzing these measurements using statistical methods, reporting relationships and associations among the studied variables. Quantitative research is descriptive and/or explanatory and can ideally be used to generalize findings depending on sampling techniques used. The population for a quantitative study could involve people, texts, or people and texts, and or a corpus of social artifacts such as media reports, etc. It can be used to quantify behaviors, opinions, attitudes, and other variables. It is less biased and more objective. It is largely used to study large samples and populations, but is just as well used for smaller populations as well. Various types of quantitative designs exist, and I'll discuss just a few basic ones, namely the descriptive, correlational, quasi-experimental, and experimental designs. Okay, these are some of the basic designs that you need to understand before you actually embark on your research study, while you're developing your research question and understanding your research problem. The descriptive design is the most simple design of quantitative methods. The descriptive design seeks to describe the current status of a variable or phenomenon. The researcher does not begin with a hypothesis, but typically develops one after the data is collected, where applicable. Many times, researchers simply use a research question. Data collection is mostly observational in nature, and we use descriptive statistical analyses to understand our data. We move on to the continuum of quantitative designs, and we move to a correlational design. Here, we actually explore the relationship between variables using statistical analyses. However, although we look at relationship and association between variables, we do not look for cause and effect. And therefore, it is also mostly observational in terms of data collection. And we move a little further than descriptive statistics, and we use inferential statistical analysis methods to understand our data. Moving further down the continuum of research designs in the quantitative methodology, we go to the quasi-experimental design, which is often referred to as causal comparative. It seeks to establish a cause-effect relationship between two or more variables, which was not done in the correlational study, right? In a correlational study, we only look at association between variables. We don't look at cause and effect. Now we move on to the cause and effect designs. All right. But now in the quasi-experimental design, there's no random assignment of subjects. So the researcher does not assign groups and does not manipulate the independent variable. The control groups are identified and exposed to the variable. Results are compared with results from groups not exposed to the variable. Again, we use inferential statistics, but more advanced types of inferential statistical methods. Right. On the continuum of designs, the experimental design is often called the true experimentation, which uses a scientific method to establish cause and effect relationship among a group of variables in a research study. Researchers make an effort to control for all variables except the one being manipulated, the independent variable. And here we do have random assignment of subjects, unlike the previous quasi-experimental design. And the effects of the independent variable on the dependent variable are collected and analyzed for a relationship. And there might be even more complex experimental designs. And I'm just discussing the basics here. Again, we use inferential statistical methods, but more advanced and more complex types of inferential statistical methods. So if you're choosing this design, you need to understand what types of inferential statistical methods there are, what type of designs there are in the experimental design collection. So you need to understand these things before you actually embark on your study. So what isn't quantitative research? Quantitative research is not exploratory. It is not a quick fix for poor research protocol. It is not a method that will give you in-depth insight into a phenomenon. It is not without its limitations. And it is not a method to be used to infer correlation and causation if the research is not designed for this purpose. So what do you understand from what we've done so far? It's very important to understand your research goal, your research problem, and your research design before conducting the study. And once you understand your research design, you need to understand what types of analyses are you going to apply on there? What type of data are you going to collect? What type of samples and populations or population are you going to use before you actually conduct the study and continue with the research design, before the empirical aspect? Important terminology in quantitative research: variables. These are measurable parts of a construct. Numerical system means using numbers and percentages to present results. Statistical methods. These are methods used to interpret numerical data. Relationships and associations. These talk of association between variables such as correlations. I'll explain this further. Research questions. This is actually a question asked to answer the intended research problem. And hypothesis, what are these? So unlike a research question, a hypothesis is a statement that you need to prove or disprove. All right, we'll start with variables. Are variables the same as constructs? Then what are concepts? This is so confusing if we don't know the basics. There are three important elements that you need to understand here: concept, construct, and variable. We begin with a concept. It is derived from exploration. That means from qualitative research, observations, experiences. And then once a concept is refined, we get to develop a construct. It is attained from theoretical exploration of a concept. So we need to do a literature study of previous studies that have been done, and we actually come to a construct, which is less abstract than a concept. And we go into something that's more concrete and measurable, which is a variable, which is derived from a construct once we actually break the construct down into measurable elements. So, like I said, a concept is the first step in the measurement process. And then researchers generate concepts by generalizing from particular facts. For instance, job satisfaction. Okay, it's now a concept. And lots of people understand satisfaction and job satisfaction to mean different things in different places. It could mean different things in a home. It could mean different things in a job place. It could mean different things in different places, all right? So it's abstract at the moment. It's based on our experiences. And it's a very abstract notion which can be developed into a construct through theoretical operationalization and contextualization. Context is really, really important as well. So when you talk of a construct, in quantitative research, we refer to constructs before we move on to a variable. But remember, in qualitative research too, we can talk of constructs. We move further in quantitative research from a construct to a variable. I'll explain that now. These are based on theoretical conceptualizations, which you derive from the literature. You'll get different descriptions and definitions of the phenomenon depending on different contexts. In a social science, a certain construct might mean something different from the natural sciences, or from different areas, from different contexts, different countries. It might mean different things in different places. So you need to actually develop these different theoretical understandings of your construct. For instance, job satisfaction, which I'll describe a bit more further. It is not directly observable or measurable. Therefore, we need to break this down further to get a variable. All right. Although this is an abstract notion of a phenomenon, it is less abstract than a concept, right? Because a concept can have so many different meanings because we haven't read all the literature based on context, all right? So although we have refined it a bit more, it is still abstract. And the most concrete of this is a variable. So can you see we move from a concept to a construct to a variable? You will speak more of variables in quantitative research. These are directly observable measures, can be measured quantitatively. They derived from the constructs, and they operationalize from the construct into a measure that you can observe empirically. Let me give you an example of the job satisfaction. So it was a concept meaning so many different things in different places. So now we want to refine this. So we try to operationally define the construct. When we operationally define it, we say job satisfaction is a term used to describe how content an individual is with his or her job. And it includes indicators like, now when these indicators actually become your variables, attitude towards present job, satisfaction with pay. Can you see now we're getting context, because this is within the context of a company or a workplace where you're actually getting paid for your work. Because someone working in the home might say, you know what, I'm working in a home, but I don't get paid. I'm a mom, I'm a dad, I stay at home, I work. That's also a job. But can you see the context is being revealed here when we talk of different elements? We talk of satisfaction with pay. So we mean in a workplace where you actually get paid, satisfaction with promotion opportunities, satisfaction with coworkers, satisfaction with supervisors. So can you see a context is created here, and we're getting a refined set of variables to understand job satisfaction, which we can empirically investigate. What does a numerical system mean? It means that your results are presented as numbers, that's percentages, frequencies, etc. Any number of sorts. Statistical methods, all the data gathered are analyzed using specific techniques and tools. You can use different methods such as Excel, or you can use different statistical packages such as JUMP, etc. So we have different statistical packages that you can use. There's an open source one called R. There's lots of different statistical packages that you can use. Statistics deals with every aspect of data, including the planning of data collection in terms of the design of surveys and experiments. So you can't just go out and give any instrument out or conduct any study and then do the statistical analyses when these instruments are not correct. There are lots of rules and regulations related to the development of different instruments and measuring constructs and variables, right? There's lots of rules related to that because we're using a scientific system for measuring variables. So you need to understand all of those before you actually go out and do your study. And these all depend on the goal of your research and your research design. Relationships and associations, these actually mean different things. So let me explain them to you. Association is a connection between two social phenomena demonstrated by one tending to vary according to variations in the other. Causality is a special case of association when changes in one systematically result in direct changes in the other. Can you see association is one level? We move to the next level, which is causality, and that means a different research design. Within experimental research, researchers are primarily interested in determining probable causal relationships in a controlled setting. Within correlational research, researchers are primarily interested in determining non-causal relationships among variables. So more specifically, the correlational research design is a type of non-experimental study in which relationships are assessed without manipulating independent variables or randomly assigning the participants to different conditions. Correlation does not imply causation. So this is really important information, because many times researchers use words without understanding the context, without understanding the implications of all of these terminology. Research questions. A research question is quite simply a question that your research intends to address. For example, what is the difference in the daily calorie intake between men and women in London? What is the relationship between disposable income and location amongst young adults? Your research does not necessarily need to answer the question in black and white, but it should explore the question, providing detailed and analytical justifications of how and why it is or isn't answered. Research questions and hypotheses are tools used in similar ways for different research methods. Both hypotheses and research questions are written before research begins and are used to help guide the research. Hypotheses, what are they? Okay, when we talk of a single hypothesis, let's begin. The intention of your research is to prove or disprove your hypothesis. You do not necessarily need to provide a black and white answer, but you must ensure that you have covered the issue at length and provide critical analysis of the outcomes. Example, children grow more quickly if they eat vegetables. Okay, we move on to sampling. Sampling means choosing a research set from the population. And this is important when we want to understand generalizability. What does generalizability mean? The extent to which we can generalize the findings from a sample to an entire population regardless of context. The sample has to be representative of the research population, requires a prior determination of the population that will be represented, which also limits generalizability to that specific population. This version of generalizability is determined by well-defined statistical procedures. You can only generalize to a population from which you sampled. Speak to your statistician before the implementation of the study to understand these basics. Sampling techniques. Probability sampling techniques are most important for ensuring generalizability of results, as these techniques use random sampling techniques to draw a sample of research respondents. Non-probability sampling is not appropriate if you want to generalize results to the population, as these techniques use non-random processes like researcher judgment or convenience sampling. So make sure you understand these, and there are different types of probability sampling techniques and different non-probability sampling techniques, which are very important dependent on what you want to achieve, on what your research goals are, what your research problem is, and what your research design intends to do. Limitations: small sample sizes. To ensure generalizability of results and to minimize sampling error and bias, Sample sizes have to be of a certain size, depending on the size of the population and what you intend to do. So you need to determine all these things. Is my sample size appropriate for the type of data that I want to collect, and the results that and the problem that I want to solve? Sampling error: the deviation of the selected sample from the true characteristics, traits, behaviors, qualities, or figures of the entire population due to sampling bias. So you need to understand what is sampling error, what is sampling bias, how this can occur, and how to avoid these before you actually start your sampling and your research study. Sampling bias, also referred to as sampling selection bias, and refers to errors that occur in research studies when the researcher does not properly select their participants. Ideally, people participating in a research study should be chosen randomly while still adhering to the criteria of the study. So this is an important aspect. You need to focus on sampling and understand what sampling size is, what sampling error is, what sampling bias, so what is appropriate for your study, and to ensure generalizability of your results to the population. Next, we come to validity and reliability. These are important to consider, especially of the data collection tools, when either conducting or critiquing research. Validity implies the extent to which a research instrument measures what it is intended to measure, and it is defined as the extent to which a concept is accurately measured in a quantitative study. For example, a survey designed to explore depression, but which actually measures anxiety, would not be considered valid. Discuss how you have ensured the validity of your instrument. Various statistical measures could be used depending on your specific study. Discuss this with your statistician before implementing the study, because many issues of validity are also statistically proven. Reliability. This refers to the degree to which a scale produces consistent results when repeated measures are made. A reliable instrument is not necessarily a valid instrument. The second measure of quality in a quantitative study is reliability, or the accuracy of an instrument. So, a simple example of validity and reliability is an alarm clock that rings at 7 each morning, but it is set for 6:30. It is very reliable. It consistently rings the same time each day, but it is not valid. It is not ringing at the desired time. Discuss how you have ensured the validity of your instrument, the validity and reliability. These reliability also, there are certain aspects that can be tested statistically, and speak to your statistician about this before you actually start with your study or decide on your instruments. Once you have a measuring instrument, you need to understand what reliability and validity issues exist and what needs to be done before you actually implement the study. Now we move on to construct development. So operationalization and itemization. Okay, operationalization means the process of developing indicators or items for measuring identified constructs. Just the way we did with job satisfaction, we found lots of information from literature reviews, and then we defined it, and we found certain qualities and elements within that. So the process defines fuzzy concepts and allows them to be measured empirically and quantitatively. For example, a scientist might propose the hypothesis, children grow more quickly if they eat vegetables. What does the statement mean by children? Are they from America, Africa? What age are they? Are the children boys or girls, or boys and girls? Can you see what we mean now by operationalization? It creates the parameters of your study. Itemization. It is hard to measure certain phenomena, such as stress, for example, but it can be represented by observable behaviors or factors, just like we see in the one for job satisfaction. So these factors are called items within a construct. those items that we seen within job satisfaction, those statements, each of those statements were items within the construct of job satisfaction. All right, and all those items together formed the construct. So a construct cannot leave out a single item once they have been developed and tested for reliability and validity. All right, so those are also statistical measures and types of studies that you need to do before you actually go out and do the study. Items within a construct are derived from various levels of investigation and analysis to ensure validity. I've just mentioned that. And constructs should be reported as summations of the items within a scale. For example, stress is a construct. It might contain items such as 1, time management, number 2, organizational climate, number 3, fear of failure, number 4, education, number 5, lack of experience. So if stress is made up of all these different items, when you are testing it, you need to actually send out your questionnaire in that way with the entire construct, with those items, and when you present the results, you need to provide a summated scoring of all those items within the construct to actually understand the stress levels of each of the individuals in your study. Finally, we come to stats basics, the statistician. This is really, really important in a quantitative study. When do I meet my statistician? What can he or she help me with? What is my role in this relationship? These are important aspects. You need to visit your statistician before you actually go out and do your study or finalize your instrument. You need to actually do all your reading, find out about your research problem, find out what you want to do, how you want to do it, go meet your statistician. Speak to your statistician about your research design, your research problem, your research question or hypothesis, the type of analysis you intend to do, the type of population you have, the type of sample you intend to include. And speak to your statistician, because some of these things might not be appropriate for the study you're doing. Your statistician can already put you in a straight line before you conduct a study. You cannot go to a statistician after you've conducted the study, after you've selected your population, after you've done everything. You need to start with your statistician before all of this. You need to speak to your statistician before you finalize an instrument, because validity and reliability needs to be established. You need to speak to your statistician prior to conducting the study, after conducting the study, and then once when you're done and you have all your data, then again speak to your statistician. So statistician doesn't just come in after data collection, it comes in way before the instrument is also finalized. I hope you've enjoyed the study, and if there are things that you do not understand, it is imperative to study those aspects further. Study those aspects further and go into more depth with them. All the best.